Hey everyone, Mr. Skelton here, back at it. Starting Unit 4 today, and we're going to get into Lesson 1, which is the Introduction to Polynomials. And we're going to start off, first of all, just by talking about the word polynomial and what it means. And if you take the word polynomial and break it down into two parts, poly means many, and nomial means terms. So we have many terms. And as we go through this, we're going to be classifying some polynomials. As we go through this lesson here, you'll see we'll talk about how to name a polynomial by the degree, and we'll talk about how to name a polynomial by the number of terms. We're going to get into a little bit of graphing as well, just some basic graphing, and then we're also going to get the scientific calculator out, and I'll show you how to do some of these problems and how to graph polynomials and create regression lines to some of the data points that we're going to be using. So you're going to need your graphing calculator. If you don't have it by you or next to you or around you, you may want to hit pause and go find that, dig it out of your bag, because we will be using that today, and you will be expected to use it on homework quizzes and probably tests when we get to that point. All right, so this first slide here is just an example of polynomials, and so it's not what I want to make sure I'm clear on this. This is not a certain type of problem that you're going to have to use on a quiz or a test or homework. This is just kind of a real world example, okay, of what polynomials are and where you can kind of see them. So I don't want you to get too worked up if this doesn't flow the way I intended it to flow for you. So basically what we have here is, and I'll explain it, is you have Jimmy, and he's 10 years old, and his parents give him $1,000, okay? And he's going to plop that into a savings account. And after 1 year, what this represents is the $1,000 gets multiplied by X. Now that X is representing like a percentage. So let's just say, you know, it's in a savings account making 5%, so like 0.05. Again, I'm not actually doing any math. This is just an example. All right? And so whatever X is, and again, I'm just making something up, 5%, that $1,000 she didn't touch, it gets multiplied by the 0.05, okay? Actually it'd be 1.05 if I'm multiplying it. And then this 1,200 represents another installment of money his parents gave him. Okay, so it's just random. When he was 10 years old, they gave him $1,000. When he was 11 years old, they gave him $1,200 on top of the 1,000 that's already in the bank earning X amount of interest. When he's 12 years old, that $1,000 that he received when he was 10 has now been in the bank for 2 years. So that percentage has been basically squared because it's gone through twice. The $1,200 that his parents gave him the year before now accrues the interest 1 year because it's been in the bank for 1 year, and then this $800 represents another $800 that his parents just gave him to start the new year. Okay? When he turns 13, now that original $1,000 has been in the bank 1, 2, 3 years, so that interest has now been tripled essentially, or accrued 3 times. The $1,200 is now twice. The $800 has now been in there for a full year, so that gets the interest. And then $1,500 is what they gave him when he was 13. And then we can go through this little game all the way, you know, however old we want to be in. So when he's 14, that original 1,000 has now been in the bank for 4 years, accruing the interest 4 times. 1,200 now has been in the bank 1, 2, 3 times, the 800, etc., etc. Okay? This right here is an example of a polynomial. Okay? Many terms, right? Polynomial. So this is what we call standard form. Standard form of a polynomial means that the highest degree goes first, and then it's descending order. So when we talk about this polynomial, this would be a degree 4 polynomial. Okay, and we'll get specific here in a minute. But you can see it goes 4, 3, 2, 1, and none. That's called our constant, okay? So when we're talking about standard form, it always has to deal with the degree, the exponent, okay? And it always goes from largest to smallest. What we're going to do next here, I believe it's on the next page, is we're going to do what I was just kind of talking about at the very beginning, is we're going to classify or name polynomials by their degree and by how many terms, right? This is we would call this a degree 4 polynomial, and there's 1, 2, 3, 4, 5 terms. So when we turn the page here and we start talking about classifying these polynomials, here's the degree. So there are more than this, okay? You know, there can be a degree 6, degree 7, degree 8, but these are the ones that I want you to kind of memorize, all right? You're going to have to know these names for homework, quizzes, and tests. So you have, if you just have a number or a constant, like 5, okay, that obviously does not have a degree. Linear would be like 3x plus 2. That would be an example of a linear by degree. Quadratic, we just spent a whole unit on quadratics, right? X squared plus 3x plus 7. That's an example of a quadratic because it has x squared as its largest degree. Cubic is anything x to the 3rd. Quartic is anything x to the 4th. Quintic is anything x to the 5th. Anything more than this, you can just say, like if I had something of like x to the 7th, we would just say, I would expect you to write on your paper degree 7 polynomial. We don't have a name. See, these have names, okay? So by their terms, that means how many terms there are. Terms are usually broken up by addition or subtraction, okay? So a monomial is one term. Well, you can have a monomial that looks like this, 5x to the 3rd. That's just one term because it's together with multiplication. Binomial is like x plus 3, right? Or, you know, 2x squared minus 7. That's an example of a binomial. One term separated by a subtraction sign or broken up by a subtraction sign. Second term, one term, two terms by binomial. Trinomial, like 5x squared plus 3x minus 7. That's a trinomial. 1, 2, 3 terms. There's addition sign, subtraction sign, so that's breaking them up, okay? So if we go back to our original, with the example I was giving you with the money, how would you name this? Well, this would be a quartic. 1, 2, 3, 4, 5. Quartic 5-term polynomial. That's how you would name this, okay? And like I said on the degrees, once you get past 5, we just say degree 7. Once we get past 4, you know, if you had something like x to the 5th plus 4x to the 4th plus 3x to the 3rd plus x plus 7, how many terms is there? 1, 2, 3, 4, 5. So this would be a quintic because the degree is 5. This would be a quintic, and then 1, 2, 3, 4, 5, 5 degree, or 5-term, sorry, 5-term polynomial. Okay? And so you'll have some questions on that, how to name it, put it in standard form. Standard form, again, is highest degree to smallest degree, and that's what we'll do. So we're going to do that right now with some examples. So it says write in standard form and then classify 2 ways. In 2 ways, I mean by degree and by the number of terms, which we just talked about. So we're going to have to do some math here. Why don't you hit pause and try this one and see what you come up with. Okay, so we're obviously going to do order of operations here. This is a multiplication really in between here, so I got to have 6x to the 3rd. 3 times 2 is 6. X squared times x is x to the 3rd. And that becomes 12x squared. And I'm going to distribute here, so it's going to be 4x squared. That'll be plus 8x, and then minus 2x, and then minus 4. And I'm going to put my like terms together, so I'll have 6x to the 3rd. That's going to be 16x squared, because I have 12x squared, 4x squared. 8x minus 2x is 6x minus 4. Now this minus sign here, remember, treat that like a -1 and distribute that through, so that becomes a minus 6x to the third minus 6x. So minus 6x to the third minus 6x. And let's put our like terms together. You have a 6x to the third and a minus 6x to the third, so those will cancel out. You have 16x squared, and then 6x and a minus 6x, so those actually cancel each other out, minus 4. So that is in standard form. After all that work, we get 16x squared minus 4. So that is in standard form. Now we need to classify it or name it in two ways. Based on its degree, it's degree 2. So if you come back up, anything with degree 2 is a quadratic. And it has two terms, right? 16x squared, there's a minus sign, there's a second term 4. So this would be a quadratic binomial. Quadratic, degree 2, binomial, 2 terms. That's how we would do that problem. Okay? All right. This is going to be a little bit maybe challenging for you. This is some graphing calculator stuff here, so we're going to do our best. I'm going to zoom out. And what we're going to do is we're going to plot these points on our calculator. We're going to graph it, and we're going to find a model, which is code for an equation that models this situation. Now, before we get into the graphing calculator, I actually want to go back to classifying. And when we talk about graphing, I want to give you just a general idea what the graphs of these look like, and I'm just going to focus on the first three, so linear, quadratic, and cubic. So I'm actually going to do it on this piece of paper here, on this slide, because we're talking about it. Most of you know what a linear function is going to look like, right? If I have, that's like y equals mx plus b. So if I had y equals 2x plus 3, right? If I were to graph that, what does that look like? Well, that's just going to be up 3, 1, 2, 3, and then up 2 over 1, and I'm going to have a line. Linear functions that just have a degree of 1, right, are graphed that way. Quadratics, you just got done doing quadratics, right? So like y equals x squared. What does a quadratic look like? A quadratic is just your parabola opening up, okay? Or it can open down if it was negative. So those two you already know. Now, one that you're going to see quite often is a cubic. That's degree 3, so like y equals x to the third. Y equals x to the third kind of looks like a snake. It kind of goes down, dips, and then comes back up, right? And we haven't got into the opposite if you had a negative, but it actually goes the other way. It's just reflected, okay? But the cubic function kind of has this kind of shape to it if it's cubic. That's what a cubic function looks like, or it can go this way, the opposite way. Okay, so it's kind of got that little dip. The reason I'm showing you that is because when you plot these points and you turn on your scatter plot, which we'll go over on the calculator, you may see the scatter plots look like this. So I want you to be able to recognize the difference between linear, something in a straight line, parabola, okay, or cubic. Quartic, when we get into quartic, which is 4, and we won't see a lot of this, but quartic basically looks just like the quadratics, okay? And once you get past quartic, like quintic, which is 5, anything that's even is going to open up like this, okay, or down. Anything that's odd kind of has this snake look to it. And I'm not going to get super into detail with you because you really don't need to know it right now. But if you can just remember linear, quadratic, and cubic, you should be in good shape. Okay. So, turn on your graphing calculator and see if I can get this out of the glare a little bit. Kind of, sort of, maybe. All right. I always reset just to make sure. So 7, reset, yep, reset. Okay. What we want to do is we want to put this data into our graphing calculator. So normally this is the first thing, the first row is your x's, and then your second is your y's. And so what we want to do is we want to go to stat. And when we hit our stat button, it'll say edit. We want to edit. And we want to list. L1 is going to represent our first list, or our x value. So I'm going to type in 1940, and then I'm just going to hit my down arrow, and then 1950, down arrow, 1960, down, 1970, down, 1980, down, 1990, down, and 1999, down. And I'm going to click over, hit my over button, and then I'm going to type in all the values that are associated with the corresponding year. So with 1940 is 22.71. You can hit just enter. 29.03, 81.73, 123.82, 321.1, 550.5, and 757.71. Okay? So all my data points are in there. If I hit graph, you'll see nothing come up, right? Because if you think about it for a second, your x values start at 1940 or 1,940, and right now you're at 10. So we're going to have to adjust our windows. Now, before we do that, because these are all points, right? X comma y, x comma y, x comma y. We want to turn on our stat plot. We want to turn on a scatter plot. So I'm going to hit quit. Second y equals. Right now your plots are off. So we want to hit enter on one, turn it on, so hit enter again. And this part just says the type. You want to make sure your lists are your x values. We talked about our x values are in list 1. Your y values are in list 2. We're all good. You can just hit enter again. Okay. So now I have it on. If you hit graph again, nothing's going to show. So let's adjust our window. So what do we want our x min to be? Let's make our x min be 1930, because our minimum amount is 1940, right? Our x max, the question says find a cubic function. So cubic function, that's important. Cubic means of degree 3. And then use the function to estimate what the Social Security benefits will be in 2005. So we want our x max to be at least 2005, so I'm going to just say 2010 will be my x max. And I want my scale to be every 10 years. So on my graph it'll show up every 10 years. Okay. My y's, I can make my y minimum just, I can keep it as -10, it's not a big deal. My y max, I'm up 700, I'm gonna maybe go 1,000. And I'm gonna make my scale, I'll go 100. And let's see when I graph these if they show up. There you go. Okay, so there's my plots. Now you can look at this, sometimes you can look at it depending on how many data points you have and figure out, is that a linear function? Is it a parabola? Is it a cubic? So you know it's not linear, right? It's not these data points don't make a straight line. It's not really a parabola because it would be, you'd have data points coming back up the other way. So it tells you in the problem it's cubic. So we know it's going to be cubic, which is good to know. So here's what we're going to do now. Once we've got our data points plotted, we're going to go back to stat. That's where we started. We're going to go over to calculate. And what we want to calculate, remember the whole problem, the whole idea is to create an equation. We want to write an equation or find a cubic model, find a cubic equation that models our data. So I'm going to calculate a cubic regression line. So you have a linear regression line, which is number 4, a quadratic. So if you thought it was a parabola, you would use a quadratic. We know it's cubic because it's asking us for cubic. So I'm going to use cubic. I'm going to hit 6. Now this is where your calculator and my calculator may differ a little bit. What it's asking you is cubic regression space. Well, what do you want it to, what data do you want it to use to find this cubic regression line? We want to use L1 and L2, and you can see the number 1 right above it. It says L1 and L2 right next to it. So second L1, got to put a comma in. Second L2, put another comma in. And this is where it gets a little weird. You're going to hit vars. You're going to hit Y, scroll over to Y vars, and you want to keep it, you want it to store in your calculator as a function. So you'll hit enter, you'll hit enter again, and then you'll hit enter again. And it should calculate it, and there you go. So my answer to this, where it says find the cubic function, would be y equals, my a value is 2.04 e to the -4, so we could write that out if we wanted to. It says find the cubic function below, blah, blah, blah. So we could write all these values in for a, b, and c. So 2.04, I'll just write e to the negative 4, because there's another way to do this. That'd be x to the third. Okay, my b value is negative, so minus 0.925 x to the second, right? Because that's degree 2. Your c value would be a plus 1284.0 x, and then your d value is your constant, which would be a minus 497178.2. So that is the function itself. When you go back to graph now, watch what will happen. It actually put a line of best fit through those data points, okay? Which is pretty cool. Now, we still have to answer the question, what is the benefit in 2005? Remember, your years are your x values, so if you wanted to, you could put 2005 into your x values and then solve. But we can use our graphing calculator a little bit differently. So if you go to second table, you'll see this is year 1, year 2, year 3, year 4, 5, 6, 7, 8, 9, 10, 11, 12, etc. We can keep scrolling. Well, we got to get to 2005. Well, we don't want to do that. That would take forever just hitting the down arrow. So you're going to access your table set button. So second table set. We want our table to start, I'm just going to say year 2000. So I'm just going to hit 2000, and then I'm going to hit, I can hit graph again. I'm going to hit second table, and now look at where your table starts. It starts at the year 2000. So now scroll down to 2005. So in 2005, the Social Security is going to be $955.82. And that is the answer to our question. There's two parts to this question. We needed to come up with the function, which we did there, and we needed to find out the amount, which we did there. Now, if you have a different calculator than me, there's going to be some differences in how we do this. I expect to go over this with you in class. So if you're not understanding what I'm doing on my graphing calculator, totally fine. I'll help you out with this, okay? So with that being said, I want you to try this one on your own, and then when you come to class, we will walk through this one together, all together with our graphing calculators, and I'll be able to troubleshoot some of the issues with the graphing calculator, especially if you have, like a TI-84 or something like that. So I want you to try this one. You're probably going to need to rewatch or rewind this so you can kind of follow or maybe hear it again or watch it again how I did it in mine. But some of you may be able to figure this out, and if you get stuck, it's not a big deal. We'll cover it in class, okay? All right, I look forward to hearing what you came up with for this question, and if you're not sure, we'll get your answers or your questions answered.